Okay, this is 3-1, parallel lines and planes. Now, please feel free to pause this at any time if you'd like to just take a second to catch up. All right, so let's first talk about parallel lines. I've got a couple drawn in here. Let's define them first, okay? So the definition, they are coplanar lines, so they're in the same plane, and at the same time they don't intersect. Now, you've seen parallel lines before, and you know that they don't intersect. You know that they're two lines that go straight across without touching each other. But what we're going to add in here is they have to be coplanar. Because you can have different kinds of lines. You can have skew lines. Now, skew lines, by definition, they are non-coplanar. And as a matter of fact, they don't intersect. So in this diagram I have here, I've got this one line here that is in the plane that's depicted with the red shape, and then you've got this other line that's hitting the plane over here, going behind it. You can see it, but that's in a different plane. So they're not in the same plane. So they're not parallel lines. They're skew lines. So there's two ways to not intersect. You can be parallel or skew. And just as a note, segments, rays, they also can be parallel or skew. Okay. So then we've got parallel planes. Parallel planes just simply don't intersect. So these blue planes, I've got this one blue plane up here, and right below it, the other blue plane, and they're never going to intersect. If you look at this box, if you think of this red box like any other box, and I was to ask you what planes are parallel, you'd probably think, okay, well, maybe the top of the box and then the bottom of the box, those are parallel planes because they're never going to intersect. You can come up with some other great examples, I'm sure. The side, this side, and this side over here. They are parallel planes because they don't intersect. Okay, so there's a theorem that goes along with these parallel planes. Let's see if we can pull this down. And it's right here. If two parallel planes are cut by a third plane, then the lines of intersection are blank. I actually want you to think about this one for a second. And actually, you can even look at this diagram here. I've got two parallel planes. Those are the yellow planes. Those are parallel, and so planes L and R. And Q comes along, another plane, and Q intersects those two parallel planes. The lines of intersection, which right here, AB and CD, they are, and hopefully by now you've noticed that they are parallel. And they're always going to be parallel when you have two parallel planes cut by a third plane. Okay, let's keep going on. Now let's go back to lines here. A line that intersects two or more coplanar lines. Okay, so we're on one plane now. Let's not worry about skew lines here. We're on one plane. I've got lines H and K. These lines are going along in the same plane, and along comes J. J is the transversal because J intersects those two lines. So J comes down, intersects H and K. So we call J the transversal. Okay, and it's going to become very important. We're going to talk about all the different angles that they make. For example, alternate interior angles. Okay, let's look at this again, and I've numbered all of the angles that are made. Alternate interior angles are two non-adjacent, so they're not going to be next to each other. They're interior, so they're on the inside of these lines that are being intersected, and they're on opposite sides of the transversal. Okay, so all the interior angles are 3, 4, 5, and 6, and I'm looking for two non-adjacent. Okay, so let's look at 3. The non-adjacent angle, it's not 4, so 5 and 6 are non-adjacent. but which one is on the opposite side of the transversal? Well, that's 6. So 3 and 6 are alternate interior angles. And then at the same time, 5 and 4, those are alternate interior angles. Then we've got same side interior angles, okay? You probably are starting to get the hang of this. Interior angles, so that they're on the inside of these lines that are being cut by the transversal. They're on the same side now of the transversal. So that must mean 3 and 5. These guys are same side interior angles, and then 6 and 4 same side interior angles. Okay, let's keep going. Corresponding angles are two angles in corresponding positions relative to the two lines. Okay, so let's just start with one of the angles. Let's start with 1. To get to 1, I went above the line that was being cut, and I went to the left of the transversal. Okay, so let's go down here. I'm going down to this intersection. I'm going to go above the line that was being cut, and I'm going to go to the left of the transversal. Above the line being cut, to the left of the transversal, 5. So 1 and 5 are corresponding angles. Now that you see that, you can probably come up with some other ones. 2 and 6, they're both above the lines being cut and to the right of the transversal. You've got 3 and 7, those are both to the left of the transversal and below the line being cut. And finally 4 and 8. Okay. Now, quick review. So you can pause this if you want to take another extra second to answer. First question, which lines are parallel? I've drawn in a box here. And hopefully you're thinking right now something like, okay, here comes the answers. Oops. A, D, and BC. AD and BC, those are parallel lines. So I can say AD, line AD is parallel to line BC. That's one of them. You might have come up with something else. You might have said AB and EF are parallel lines. You might have said EH and FG. Those are parallel lines. Those are all good examples. Which lines are skew? So now we've got to be in different planes and not intersecting. Okay, how about EF and CG? So I can say that lines EF and CG, are skew. And then there's, of course, some other examples that you could come up with. All right, which angle, are you ready for this? Which angle is the same side interior angle to D? So let's circle D, let's see. Okay, now we want to be the same side interior angle. So on the same side of the transversal and on the interior of the lines being cut. Okay, must be F. Good. Alternate interior angle to D. Okay, let's start at D again. Now we want to be on the alternate side. We're on the interior of the two lines being cut, but on the alternate side of the transversal, so that must mean E. So D and E are alternate interior angles. And corresponding angles. Okay, so which angle is corresponding to C? To get to C, I went below the line being cut. I went to the left of the transversal. So let's go down here. Let's go below the line being cut. Let's go to the left of the transversal. Looks like G. Okay, that's it.